Thank you. Hi, everyone. I'm Ben. I'm all the way from Melbourne in Australia, so this is my first time to Denver, so thank you for having me. Super amped. Today, my talk is called The Critical Request, and it's essentially we're going to do a study on how the browser decides to load things and why, and how we can use that to our advantage to make our apps and websites faster. How many people are interested in performance on the web? Okay, so like everyone. Keep your hand up. You're going to work with me on this one. All right. Keep your hand up if you get to work on performance regularly, like once a week. Yeah. Keep your hand up if it's your actual job. You're a performance engineer. I'm seeing 4 hands right now. All right, cool. So I think today we're going to have a lot of fun. And hopefully we can impart some knowledge on you. I'm the founder of a company called Calibre. I'm the sole founder. I'm the only person. It's a bootstrapped company. The whole company is devoted to trying to make the web a faster place. We're doing that through tooling that is about web performance and trying to help companies make their apps and sites faster. So if you're interested in that, definitely check out Calibre for sure. And the other thing too is, if you're interested in starting your own company, that's something that I'm currently doing, and I'm looking at hiring people, and I'm looking at the world of how that works. I'm a year and a half in, and it's going reasonably successfully, thankfully. So if you're interested in starting your own thing, and maybe you want to talk about some of the challenges I've had over the last year and a half, I'd love to talk to you about that as well in the break. So when we normally talk about performance, we talk about sort of rules, right? You've heard these rules before. You've heard serve less requests and compress things and bundle and minimize stuff and use asset hashing and use CDNs to put the assets closer to the user. You've heard all of these things before, right? And they're rules, and they work. They're good. If you do these things, your websites will be faster in some kind of way. But what happens once you've covered all of these other things, these rules that you've just heard, that you just follow because you know it's a thing? The concept behind this talk today is we're going to investigate what actually makes your pages slow. So I'm not saying that don't follow these rules, definitely do. But we're going to go deeper. We need to. So let's shift gears a little bit and start talking about the people that we build web experiences for. There are people in diverse locations, they're using a vast array of devices and connection speeds, and there are people with a task in mind. We all know that we might have a 4G connection. That's great when you're outside in a field next to a tower, but when you're at the wrong end of the office or in a tunnel on the train or whatever your situational connection is, that it may not really be as fast as it should advertise speed be. Now, research shows that users will only, after a second, they'll start to lose focus. And after 10 seconds, the abandonment rate rises really super dramatically. So if we're not delivering an experience to a user in this sort of amount of time, then we're probably losing them. So being that we're talking about users, we're going to need to understand what a user experience looks like with loading on the web. And thankfully, there are a bunch of metrics to do exactly that. So if we look at a loading timeline of a page, we'll see that after the user navigates, there's this first paint. First paint is when the browser goes from nothing to something, so probably from a blank page to just a background color, something like that. That's your first paint. A little bit further on, there's your first contentful paint, which is when text is rendered to the screen. And then a little bit longer after that, there's this concept of first meaningful paint. And a first meaningful paint is essentially when all of the content is visible in the user's viewport. You could describe that as content above the fold if you wanted to. So when we look at a load and render timeline, and we look at the assets that are loaded along that sort of process. We can see some requests in the background here, and we've got this, this landmark timing of onload right at the end. onload doesn't really describe something that a user experiences, right? Like everything might have been painted way before onload occurs. So onload isn't useful. What we're going to focus on today is first meaningful paint. So we're gonna investigate what happens in the browser in this sort of green section here. This is our focus for today. These requests, I'll get a little bit ahead of myself there. So that is a first meaningful paint. And we're going to look at the requests that are made up in that section before. So a critical request is one that contains an asset that is essential to the content in a user's viewport. It's not a tracking script. It's not an image at the bottom of the screen. It's not an icon somewhere hidden on the page. It's the stuff that's made up of the viewport for the user. And oftentimes, those sorts of resources are things like CSS for the content that's on the current page. They're fonts. Everyone uses web fonts. Put your hand up if you use web fonts. Yeah, actually, I think it's 79% of sites on the web today use web fonts. And we're going to focus on that particularly today. And also, pages will need a logo and usually like a lead image, kind of depending on the content type of your site. So how do browsers decide which resources to fetch? Does anyone know this? I'm not seeing any hands, but I'm guessing that you don't. You maybe know this. And I think that's an interesting sort of fundamental aspect of the web, right? We as web developers should understand how the browser decides to get those resources because it's really important. So I'm going to take you through it. The browser, we delivered some HTML in our first request. What the browser does at this point of time, it uses a read-ahead parser. So as the request, as the HTML request is being streamed down to the browser, it will go and quickly try and read ahead to find assets that are available. In the case of this page, it'll find an app.css, then it'll find a JavaScript CSS file, and then maybe after some time, it'll find a font. Now, those resources are actually chosen in a certain, in this case, you can see that the CSS is first, then we list the app.js, and then the font loads whenever the font loads, right? But there is actually more going on. So first thing I want you all to do when you, if you're using Chrome, is pop open your DevTools and then right-click on any of the little titles across the page there and turn on priority. And what priority does is it shows the priority of how the request was actually made. And I'm going to get into and explaining how that process works. So as the browser streams down the HTML and there are some assets in there, it'll assign a priority to each resource. In the case of a CSS file, it'll be a high priority in certain cases. If it's an image, it could be low or medium priority. If it's a script, it could be a range of them as well. So here's how they're referenced. HTML is referenced as highest priority. So if there's a request that pops into the order, as the browser discovers resources to download, it'll see a HTML one, bang, that's straight at the top. Really important. We want that content really fast. Styles, similar, high. Images are interesting. Images start at a low priority, and if they're going to be rendered in the top, this is in Chrome specifically. Other browsers have different variations on this. But if the image is in the top viewport for the user, it'll actually be upgraded to medium and be downloaded faster. So browsers are actually pretty clever at doing this sort of content negotiation. If you're doing XHR or Ajax or Fetch, they'll be prioritized as high. Fonts will be prioritized as highest, but there are some issues with that, which we'll cover. And then scripts, well, of course, it's because it's JavaScript. It'll be low, medium, or high. So the JavaScript request priority is something that it does seem kind of complex, but if you keep a slide like this around handy, you'll keep remembering it, understanding it. If it's referenced as just a regular old script tag, it'll be high if it's placed above an image. And if it's below an image, it'll be medium. So if you're putting your script tags right at the bottom of the page, they'll probably be prioritized as medium. If you're using async or defer or both, they'll be low priority. And if you're using the new module system, they'll also be prioritized as low. Fonts are a little bit, there's a little bit more detail going on. So when the browser decides to fetch a font, there's a couple of things that need to happen first. Firstly, there needs to be a style sheet. So your browser's probably already downloaded your main.css file. It discovers that there's a font face that it doesn't have, and it knows that it's going to need to do something to find that. So that needs to exist. The second thing is that there needs to be a corresponding @fontface declaration. OK, cool. And then the third thing, which is an important detail, is that there needs to be text to render. So if you're building like a single-page app, anyone building single-page apps? Whole bunch of people? OK, cool. So if you're not rendering anything to the page, and you're kind of waiting for all your JavaScript to download and your modules to get popped in, and then initialization, and if you're not rendering any text at all, you're actually delaying the browser from fetching that font file in the first place, which can delay that paint even further. So what we're going to do today is I'm going to show you how you can do an audit in your browser, just using tools on your machine already. And we're going to look at ways of making a site faster. Does that sound fun? Yeah? Cool. All right. So my target for today is Atlassian, only for the reason that I looked around a few pages, and I found that these the performance issues that were on this page were easily reproducible, and there wasn't like a lot of like ridiculous font loading and all that sort of stuff. It was fairly straightforward. It's actually a super beautiful site, and it does perform pretty well until you slow the network down to like on a 3G connection. And so we're gonna study through that, and I'm gonna show you some stuff along the way. So first thing that you're gonna do if you're gonna perform an audit, you want to test using the poorest conditions that your users could face. So if you're using Chrome DevTools, pop it open and click on the Performance tab, which is a little bit of a scary tab, but I want you to come with me on this journey. Turn on screenshots and slow down your network reasonably significantly to a fast 3G connection, and slow the CPU down as well to 4x. In my tests, turning this current model MacBook to 4x kind of brings it to performance that's similar to like a Nexus 5. Phone, which is still above the global average of smartphones, but at least it's representative of what users will face. You may want to slow it down even further, but the important detail here is that if you're using a $3,000 computer on your company's fast network, you're not experiencing the web in ways that your users do. So what we want to do is exacerbate any performance issues that may be there, and we want to really, really highlight them. The second thing that you want to do, once that you've done that, in this case, I've just popped DevTools over to the side, and I've used the responsive mode so that I could fit everything in the screenshot. And so go to the site that you're going to test, and once that's fully loaded and everything, now we're ready to test. And then we're going to click this little refresh-looking icon here in the DevTools. And that's going to start profiling the page. And so effectively what it's doing is it's reloading the page. I've also disabled cache, which is an important detail. So I've disabled the cache. I've set the network to be slower. I've set the CPU to be slower as well. I've hit this refresh button, and it's going to start getting a whole bunch of data about what the browser is doing internally to get that page down and rendered. So now that I've got a performance trace, we're going to see a whole bunch of stuff in the browser, and it can be kind of a little bit overwhelming. The little charts that you can see across the top are color-coded. So in the case of the purple activity and that sort of wavy area up there, that's when the browser is painting. So those are like major paints. The yellow is when we've got JavaScript execution. If you look a little bit higher, up around the 11-second mark, there's those little red blocks. That's indicating that the JavaScript main thread is receiving sort of lots of long tasks. And on a phone, what that can do is effectively, everyone knows that thing where you're sitting on the couch and you're reading a news article, and you scroll down and it doesn't scroll, and then it scrolls all the way to the bottom, and then you've tapped an ad, and then you're in another page, right? That's effectively like the main thread being blocked. And so on your $3,000 computer, that doesn't happen because the CPU is really fast, but on your phone, it's not quite the same. Anyway, so what I'm doing here is I'm I'm mousing along the screenshot timeline, and I'm seeing that the fonts take a little while to load, right? Like we kind of have some of the pages there, but the text isn't readable. And then if we, yeah, so you can see that right there, exactly. And so I scroll down through these requests, and we can see that the web fonts, there's 3 web fonts, and they're being loaded as, I think it's like the 30th request or something like that, right? Like it's underneath all of these other images. In the case of this page, they're all images, and a lot of these images are way down the page as well. So those resources are resources that we do need, but we just don't need them now, right? So the first thing that we can do is we can actually use this brand new or reasonably new thing called Preload. And you can do that by adding this HTML tag to your page. In this case, I've done it for a font, because we've identified, first thing is that we've identified that the page is being delayed by fonts. So we kind of want to be able to say, hey, let's go and get these fonts now, right? Like the browser can't know, because the browser has to go and download the CSS, and then it has to parse it, and then it has to look through the doc. Oh, there's a font there. Oh, okay, have I got the font? No, let's go download it now. That's far too late. So what we're going to do is we're going to tell the browser, hey, you don't know it yet. We do. Go and download this. You can also do this as a HTTP header. So if you wanted to do it not in your HTML, you can be a little bit more clever, and you can tell your page, go and get this resource immediately. And yeah, the cross-origin attribute is required for fonts. For other resources, you don't need it. OK, so again, back in DevTools, there's a really cool feature that most people don't know about, I'm guessing. I'm not going to ask you to put your hands up for everything, but you probably haven't seen this before. So with my performance, I've got a performance trace currently, right? So I click over into sources, and I enable local overrides. Then the browser will say, like, where can I store these local overrides? And I give it a folder on my desktop, because my desktop is full of icons, and that's just the way I work. And what it actually allows you to do is you can go to the request window, and then you can say, edit this in local overrides. And in the case of this page right here, like, I don't have commit access on Atlassian.com, right? I haven't asked, but I don't think they'd give it to me. So what I'm going to do is I'm going to use this local overrides feature, and I'm going to slightly modify their HTML to my advantage, because I've got a theory, right? Like, my theory is that the fonts are delaying render. So I use local overrides. It's a little difficult to see. It doesn't really matter. But what I've gone and added to this page are these 3 lines. I say, link rel preload, the book, the medium, and the bold version of this font. We need all 3 for the page to be able to be rendered. Here's the result. So before preload, it was taking 5 to 7 seconds before any text was visible. OK, so what happens after preload is those fonts are moved up to, remember the priorities that we talked about? Now the fonts are at highest priority. So they get bumped up, and they're actually downloaded before the CSS. So what's really cool is that this is where the text gets rendered. So we've pulled that back already from like 5 to 7 seconds with like this one tag that will take you 5 minutes to put into your page. And as I said, like nearly 80% of the sites on the web today use web fonts, right? So if you can just add 3 little tags to your page and drop a couple of seconds, that's pretty cool, right? Yeah, I agree. So yeah, it bumps it up before the CSS. As soon as the CSS is available, and as soon as the fonts are available, as you can tell, the fonts are usually a little bit bigger, and there's 3 requests to make. But as soon as they're downloaded, they'll be displayed and painted. But we can actually do a little bit more. There's also a thing called font Splay swap, and this is kind of new-ish as well. And if you host your own web fonts, you can use this too. And there's a couple of different options, but swap is my favorite. And essentially what it says to the browser is display, like we've got a font stack, right? Like it might be like, in this case, circular, and it might fall back to Helvetica or something like that. It'll say display Helvetica until we've downloaded this font, and then just swap them out, right? So it means that the user isn't waiting for text to be rendered at all, which is fantastic. There are other options, like you can say like the current blocking mode, like you've got control. That's what the browser does now. It just doesn't render anything until the font's available. You can also, there's an option called optional, which lets the browser decide if the font hasn't been downloaded in a certain amount of time, just don't bother with it, right? Just give up on the fact that that web font can exist. That might work for you. It depends, but I think swap is really the one you want to use. So before font display, this is what our load and render looked like. We were rendering here. After font display, that's when the text gets rendered. And that is the coolest thing, right? I mean, this is the browser. This is 2018. Why are we waiting for people to have text to render to the screen? That's ridiculous, right? So this is fantastic. As soon as the HTML is available on the device, bang, we render. Super cool. There's also a really cool tool by Monica Dinilescu, not a Waldorf on Twitter, called the Font Style Matcher. And the concept of this is, say you've got a font stack. So say I mentioned like the circular font and then Helvetica. Those two fonts aren't really the same, right? They might have different X heights, they might have different line heights, they might be tracked differently. What this tool allows you to do is specify a Google font and specify your fallback. So in this example, it's the Georgia font and Merriweather. And it lets you tweak and see those two fonts rendered over each other. So you won't have that thing where like the user is like, you've already rendered the text, fantastic. Users start scrolling down the page, and then suddenly they lose their spot in the article that they're reading because the font is a completely different size. So if you were to use like a font loader or something to like add a class to your page to say like, oh, at the moment I don't have a web font, so like let's track out the characters a little bit. But now I do have a web font, so let's change that, right? And so we can have a really nice fallback where it tweaks, and like you might not even really know, you might not notice that the brand font is there. All the designers on your team will, of course, but you know we're not building for them. So if we're gonna like look at what happened in that little audit that we did right there, the first thing we did was we used link rel preload. We then used font display swap to ensure that text was always visible. We're suggesting that you should use font fallbacks that look similar so that you know the fallback isn't too jarring for the user. And like a bonus one is use WAF2 if you can. WAF1 was a compressed format, but if you use WAF2, it's compressed even more. And there's good browser support for this. You might have to poke your font foundry. Not a lot of people are putting out WAF2, but there's definitely some advantages there. An experimental thing that is actually available in Chrome now, today, it's hidden behind flags, and I can help you find those if you need them. This is a new proposal put together by a couple of people at Google who were really interested in how preload was changing the way that people were thinking about resources. And the idea is that other asset types, you could maybe specify like, hey, this image is right down the bottom of the page. It's not a high priority, so let's mark it as that, right? And then another sort of idea there is that if we were doing a fetch call, like for some content at the bottom of the page or something like that, we could mark that as low importance as well. So this, you know, it's an experimental thing. It's available in a browser now. You can sort of mess around with it yourself. Maybe it's something that we'll be using in the future. So for an audit checklist, let's see. We're going to test in poor conditions to highlight performance issues. We're going to use the performance panel to explore the relationship between render, asset fetching, and like paints and JavaScript. They're the kinds of things that we're looking for, right? Like that performance panel has a whole lot of information about the paints and like how long a function call takes, and there's a lot of depth in there. You know, as a kind of finger in the air guesstimate of how a page renders, you can look at that timeline, that color timeline where it's got purple and yellow and those colors in there. And if you can see a lot of JavaScript main thread activity, it's kind of indicative that maybe you're serving a lot of script and a slow device would struggle with that. Or maybe you've got some functions that are really particularly slow for some reason, or you're like thrashing the DOM on paint, right? Those are all things that are kind of, it's difficult to become a performance expert, but if you use those sort of signals that you see in the performance panel, they're the kinds of things that you can look for, and all of the information is there for you. The other thing is to ensure that critical requests are prioritized. So we want to deliver that content to a user as fast as we can. And again, just iterate from good to great. It's really difficult to, as I said, to do this, and there are often so many things that we could possibly do. And you're probably not going to be able to do it in one single sitting, right? So just keep working on these things slowly. So I alluded to this earlier. When I asked you, who's interested in performance, most people in the room did. When I asked how many people got to work on it, most of the hands went down. Then when I asked how many people get to do it as their actual job, it was like 4 hands, maybe 5. So getting the opportunity to work on performance is a really kind of a difficult thing to sell at your company. Maybe you've got a ton of legacy that you didn't build, or the team built when things were hard and you were working really fast, right? That happens. There's no reason to be embarrassed by that, but you do want to improve that. So how do you do that work, and when do you do it? So if we're going to look at a project timeline, if you were starting something today, this is when performance happens, and it usually goes, kind of something like this. It's launch day, or maybe it's the day after, and somebody says, hey, somebody said it was a little bit slow on a phone. Is that true? Their voice goes really high, like that, right? That's when performance happens. When performance should happen is kind of all the way through your process, right? And I know myself that I work with hundreds of organizations around the globe with Calibre. That isn't really a possibility, right? So we need, as developers and builders for the web, we need to have a bit of a framework to be able to work on performance. We can't, it ain't done till it's fast, and it ain't done till it's accessible. So here's you without a plan. I don't know how long it'll take, but I'll just hope for the best. That isn't really good enough. So what I'd like to encourage you to do is come up with something like a performance workbook that you share with your team. We're going to have some columns across here. You could take this verbatim, or you could do whatever works for you and your organization. We're going to have an estimated gain. We're going to have an achieved gain, a difficulty, and an estimate cost. So in the example that we already covered, right, we're going to preload the fonts. My estimate, based on my hypothesis, right, I jumped into DevTools, and I saw that the fonts were being delayed by 3 to 5 seconds. So my idea is that I can make that faster. I think I can do about 3 to 5 seconds. What did we achieve? About 3 seconds. The difficulty was easy, and the cost was low, right? So that's a no-brainer. You take that to your boss. It's like, I can do this in probably under an hour. Can I just let me do this? Cool. You could probably sneak that in. No one would even know, right? And that's the best kind of performance work to do. There's the font display swap. Again, that was really easy. If you're hosting your own fonts, it's easy. If you're using something like Google Fonts, you can't do it at the moment, and that sucks, and Google needs to work on that for sure. But in most cases, that's usually pretty easy. We could just remove all of the web fonts, and that sounds like a great idea, right? Everyone thinks that web fonts delay everything. It'll probably create some kind of political issues with your branding team that may be difficult to overcome, right? I mean, just deleting code is usually pretty easy, so it shouldn't be too hard to do. But what will the benefit be? And the real case is I don't know. And so maybe it is worth doing, but maybe it isn't. Let's just rewrite everything in React. I heard React was really fast. Everyone talks about, it's the most focused on performance. It'll cost a lot of money, and it'll be really hard once you get past that first example that feels real good. What will be the performance game? I don't know, right? So you're going to have to do some testing work to go and see how much, what you can achieve here. And so the only way you can do that is by monitoring frequently. We could remove all the ads, and I think that costs all the time on our page. It shouldn't be too difficult, but it's all of our revenue because that's how we make money. That's probably not going to fly with your company, right? So And then my favorite version is you just delete all of your JavaScript. Your site will be faster. It'll probably be better in a bunch of ways. But we are at a JavaScript conference, so let's just be friends after this, OK? So here's you as an intellectual. Now that you've got this workbook, you can say to your boss, like, hey, can we do some more performance work? I've summarized a couple of ideas that I have, and I can see some performance gains. All we want to do is have a shot at this. Can I run you through the details? That is a much better conversation, right, than, I don't know, I'll just do my best. So I wanted to come up with, I guess, a performance advocate's manifesto. If you're going to become a performance advocate at your company, performance, firstly, is a baseline requirement. It's a facet of user experience. You can't ignore it just like you can't ignore accessibility. It's important. Just do it. Every addition has a cost, so therefore it should have a value. So if you're going to add something to the page, it has to represent something to the user. Ad tracking is not that. And that's a little bit challenging as a performance engineer. But it just means that if you're going to add that tracking, make it good. Don't let it delay the user. Test everything that you do. Like, don't just go on assumptions of like, oh, we added a web font. I think it's going to be really slow. Actually test it and come up with some numbers, because it'll turn you into a better engineer. And draw conclusions and act on like actual data. So as I said, I run this company called Calibre. It helps people understand the metrics of their site. It looks at how the browser paints. It looks at when the browser becomes ready for use, and a whole bunch of other metrics. And it does little videos of when your pages were rendering, and it's pretty sweet. I work on it full-time, and I'm having a real blast doing that. So definitely check it out. I've been Ben Schwarz. Thank you so much.
So one thing that I was thinking a lot about, and towards the end of the talk, you got in depth in this, is that just like with testing, it's sometimes hard to advocate for the things that matter when you don't have the ability to make those decisions. So I'm glad that you went over that stuff, because there's a lot of things. It's like writing tests so that your code is maintainable and scalable, making it performant so people can actually go to it, which is a part of accessibility. And then there's accessibility in the grander scheme of things. If I were not somebody in a position that had the privilege to tell my boss, like, we have to do this, are there any organizations that can help me shame them? Besides the Google Dev Advocacy team on Twitter?
Yeah, I mean, that's kind of like, that's part of the work that I'm doing with Calibre as well. Like, I have companies that come to me and say, we have no idea what to work on. We don't know how to do the next thing. So I'll go and do like an audit, or I'll have someone do an audit, and we'll run them through kind of like the biggest ticket, cheapest things to do, and try and give people some quantitative sort of data for that. It's a real challenge, though.
Yeah, especially since you're dealing with different browsers. Are the priorities of what's loaded standard throughout all the browsers?
Each browser uses a prioritization method, but the method may be slightly different. So in the example of Chrome, it starts as low, but then gets upgraded to medium if it's in the top part of the browser. I think Firefox has something for this as well, but I'm not exactly sure of like how it does it. I started reading C code when I discovered this, and that's not what I do. So that got kind of real deep real fast, but essentially, yes.
Yeah. Are those algorithms for how they load them named after Starbucks drinks?
I didn't notice.
Okay.
Yeah.
Well, read up on that, and then if we do this next year, Steve, you can do that talk.
Jen is just really waiting for next year. Yeah.
79% you said was how many sites are using web fonts?
Yeah.
Wow. And web fonts are fairly new.
Yeah. Well, I mean,
less than a decade ago was when I remember it was was it Typekit was that
was one of the first.
One of the first companies you can sign up for.
Who was building for the web before web fonts? Tons of people, right? You remember how cool that was, where you could be like, oh, we can use more than 6 fonts. That was the coolest thing, but we kind of missed what it was actually doing.
Yeah, I mean, I thought it was like, oh, here's a lot of work coming my way.
Yeah.
I was like, I like just putting font family monospace. Actually, I still do that.
You know, you can actually, there's also font face fantasy. Yeah. And it uses like a fantasy style font, so that's pretty cool. Maybe you should swap your fonts to that.
So besides the browsers having their own sort of plan for how requests are loaded, do browser extensions affect that kind of stuff? Because I see like now, like when I'm going to a web page, I have like a password manager. Like LastPass is always trying to like inject itself into my life, and then ad blockers and stuff like that. How does that fall into the equation of paints?
I'm really glad you asked that, actually, because I didn't cover that. Yeah, I get a ton of people saying like, oh, your tool says that it's this slow, but when I test it, it's not. And that's because like everyone uses ad blocker, right? You're a professional internet user. That's what you do. But not everyone does. And like those tools sometimes change stuff about the browser. Sometimes they throw in little alerts, cause warnings and stuff like that. Basically, what you probably should do is open an incognito window or something that has like, you can also have like a Chrome, like a separate Chrome icon where you use different flags and you can disable extensions altogether, -- disable extensions. And if you do that, your browser isn't going to have that stuff and you're not going to ruin your like personal workspace. But there's also like the workspaces thing too. Yeah,
that's also whenever people do bug reports and stuff I work on, it's like incognito window, because it's out of sight, out of mind, the extensions now. You can hide those icons and you're like, I don't know what's running, but it definitely affects that stuff.
Your favorite news site, right? Like you load that and you're like, oh, I'm reading the news, fantastic. And then like, use your parents' computer and you're like, what the hell is this? I mean, it's a completely different world.
Why is this news site called McAfee antivirus?
Yeah.
Yeah, awesome. Well, thank you very much. Round of applause for Ben.